Hello, how are you? Okay, so to wrap up this course in management information systems, we're going to cover artificial intelligence and automation with module 13. We've got one more module after this. We can do it, you guys. So, learning objectives, we're going to define artificial intelligence and explain how AI technologies support decision making. We're going to describe an expert system, its applications and components. We're going to talk about core-based reasoning and the 4 R's that are involved in this type of design and implementation. We're going to talk about the 4 different types of intelligent agents and talk about how they're used. We're going to touch on fuzzy logic and what it's used for. We're going to go a little deeper into machine language than we did back in module 2. And artificial neural networks. We're going to learn how genetic algorithms are used. We're going to explain natural language processing and the major categories, which then is going to lead us into the 5 benefits of integrating AI technologies into your decision support systems. And then finally, we're going to wrap up this section with an explanation of contextual computing, discussing the impacts that AI has on automation. And then lastly, we'll talk about those ethical issues when it comes to AI. So let's start off. What is AI? AI consists of related technologies that attempt to simulate what a human might think, how a human behaves, and even how a human may feel. The AI technologies apply computer concepts to areas such as knowledge, perception, reasoning, understanding, and other cognitive abilities. Where information systems applies to storing, retrieving, and working with data, AI is concerned with the generating and displaying of knowledge and facts. Okay, so for example, in information systems, you use the data to help in decision making. In AI, you're trying to find the trends and the rules of thumb so that a computer can make a decision instead of a human. AI used in 2 types of decision-making analyses. The very first one is a what is analysis. This is typically used for transaction processing. These types of systems cannot predict what might happen in the future. It's definitely based on what is happening currently. The second type is a what if analysis. The what if analysis effects of change in one or more variables can be monitored so you can see what those changes are doing to the system as a whole. This type of system is going to answer questions like why, what does it mean, what should we do, and when should we do it. Some general applications of AI related technologies are listed here in this table. So say, for example, let's look at the last line. You have an airline such as American Airlines. AI can be used to schedule the routine maintenance on their fleet. Maintenance happens on aircraft just the way that it does on cars and trucks. Okay, so after so many flights or have so many miles per flight, they are required to have scheduled maintenance. The AI can actually read the indicators and know when those maintenances need to be scheduled and when it's due. Okay, so it's just going to automatically schedule the maintenance into the books. On the other hand, AI can be used for inventory control in several different ways. Here we can see that Hyundai uses it to deliver for delivery time reduction. SCI uses it to reduce overhead in their stored inventory. And Reynolds and Unilever use it to reduce errors, resulting in a cost savings. The next generation of AI is being called augmented intelligence, intelligence augmentation, or cognitive augmentation. The end goal of augmented intelligence is to aid the decision maker's capabilities. It's not to replace the decision maker. Big difference. It aids by helping the decision maker to work smarter and faster, complementing the decision maker. Again, not replacing them. Smart devices with AI chips are being developed. These devices can be robots, cameras, even medical devices with increased efficiency and effectiveness. In this way, augmented intelligence can help many different industries, including manufacturing and healthcare, construction, logistics, transportation, and even in security. Robotics is probably the most recognizable and successful applications of AI. AI has been proven to be very successful in performing very simple, repetitive tasks, which then can free up your employees from either tedious jobs or even hazardous jobs. Typically, these robots have limited mobility and vision. I'm sure maybe you've seen Asimo, the Honda robot, shown here in the picture. There are many YouTube videos out there. I've linked one if you'd like to go see what Asimo can do. Some of the programming languages used to control robots include variable assembly language or VAL, functional robotics or FROB, and a manufacturing language or AML. The robots like Asimo are for large organizations or manufacturing, but lately personal robots have gotten quite a bit of attention. Personal robots, again, we're talking about limited mobility, vision, and speech capabilities. Sometimes they're even used for prototyping for testing. So robots in the workplace, though, they have some very interesting advantages. They're not going to have any interpersonal conflict or personal issues, right? Because they're not a human being. They are going to be consistent with every single task given. And finally, they can function in dangerous environments and they're not going to complain about it. Another type of robot is known as a soft robot. This is going to be a much simpler and a little bit more cost-effective robot. They get the name soft robot due to the fact that their external material is typically made from some type of flexible rubber or substance. They're used primarily for high-speed food handling, adaptive grasping, advanced assembly, where a gentle touch might be beneficial, sort of like even in the medical field. Expert systems have been one of the most successful AI related technologies, and it's been around since the 1960s. The programs mimic human expertise in a particular area to solve a problem that has been well defined. In order for the expert system to solve the problem, though, humans must have already solved the problem. Okay, tasks such as medicine, education, and some exploration types are good examples. Expert systems can also monitor what customers are saying regarding specific products, and related to that, it could be used for search engines to better understand your users' queries. Expert systems are going to work with your heuristic. Me and my hard words. Heuristic data. Heuristic data includes things like common sense, rules of thumb, educated guesses, and your judgment. Your heuristic data encourages the application of knowledge based on experience to find a solution. A typical expert system includes various different components. First, a knowledge acquisition facility. That's going to be a software package containing methods for obtaining new rules and facts. This is where you can grow your system and add new human solved tasks. A knowledge base, it's going to be very similar to a database in that it stores facts and figures, but it's also going to keep track of associated rules and explanations as well. Some types of data that are held in a knowledge base include factual knowledge, heuristic knowledge, which are the rules associated to a problem, and also meta knowledge, which is just like metadata, and it's going to be the data about the data. Next, there's a knowledge base management system, or a KBMS. This is going to act as your DBMS, and it's where your knowledge base is stored and or updated. The user interface is going to provide friendly access to the expert system, and the explanation facility is going to explain how to use it. The inference engine in your expert system is going to manipulate your series of rules. The rules are going to be evaluated and then your advice is going to be provided. Okay, there are two different ways: forward chaining, backward chaining. Forward chaining uses an if then else algorithm. The backward chaining is going to start with the end goal in mind, and then it's going to backtrack to find the proper solution. For example, thinking about an expert system providing financial investment advice, forward chaining might ask the user a bunch of yes or no questions to eventually get to the advice that the user is seeking. Backwards chaining, on the other hand, might find what the user wants as the end result, say the highest percentage yield, but this choice may not meet all of the criteria that the customer has. Expert systems are used in a variety of ways in industries. Expert systems are used to monitor nuclear power plants, to assist the IRS, the USPS, and even the DOT. Expert systems can review DNA samples looking for matches, and it can even train your employees. An expert system should be used if one or more of the following conditions exist. Extensive human expertise is needed, but a single human cannot tackle the problem alone. Okay, they can then get the help of that expert system. Necessary expertise can be represented as the rules or those heuristics we were talking about. Decision or task has already been handled successfully by the human experts. Okay, this is going to require standardization and consistency. It can also involve many rules and a very complex logic that is going to be evaluated. Subject domain is limited. Okay, so maybe in your subject matter experts are scarce. That's another place that an expert system could be of assistance. Several reasons why you should not use an expert system. Some of these include the presence of too few or too many rules. Okay, if you don't have enough rules or if you have too many. Involves well-structured numerical problems that don't require an expert system. If it involves a broad range of topics, but you don't have very many rules. If you have a disagreement among your experts, okay? And last but not least, if it does require human expertise. Advantages of using an expert system include your expert system is never going to be distracted. It's never going to be forgetful or tired like me. It it can be used to duplicate and preserve expertise when your expertise pool is low. It can preserve expertise of employees who are retiring or leaving. It can create consistency in decision making, and it can improve decision making skills of those non-experts. Now, your expert-based system uses techniques such as the if-then-else method to solve a problem, but a case-based reasoning is a problem-solving technique that's going to match a new problem with an existing problem that already has a solution. Okay, each problem solution combination is stored into that database using keywords. Okay, the algorithm then is going to search through the keywords to find a problem solution combination that can be applied to the new problem by finding similar keywords. Okay, if no problem solution combination can be found, then it must involve a human expert to solve that problem. Design and implementation of care-based reasoning, you've got 4 R's. First, retrieve. The algorithm is going to retrieve the problem solution combination that most closely resembles your new problem. It's going to reuse, okay? The problem solution combination most closely resembling the new problem is then going to be reused to find the solution to the new problem. Okay, revise. If necessary, that problem solution combination is going to be revised in order to meet the needs of the new problem. And then finally, it's going to be retained. That new problem and its associated solution are then paired together and added to the database for future use. So that is how your database is going to grow with new problems. We've previously talked about bots, and bots fall into the AI category of intelligent agent. Intelligent agent is basically software capable of reasoning and following rule-based processes. So other than bots, you can call them things such as virtual agents or intelligent virtual agents. Some characteristics include the ability to adapt or to learn from previous knowledge, autonomy in order to operate with minimal interaction, collaborative behavior in order to cooperate with other agents, human-like interface to interact with users, mobility in order to migrate across platforms with minimal interaction, and finally, reactivity in order to select problems which need attention in order to act upon them. One important application of these intelligent agents is web marketing. We've talked a lot about how when you're on the internet, ads that you are shown can be tailored directly to what you have searched before, your demographic information, your location, etc. Intelligent agents are also used for virtual catalogs. These catalogs are always going to show your user products that it feels those users would prefer based on the same criteria as your web marketing. Current intelligent agents include shopping and information agents and personal agents. Shopping and information agents help users navigate through the internet, provide much better search results. Since they can work much faster than a human and gather more consistent, more detailed information, they're good candidates for search engines, site reminders, personal surfing agents, things of that nature. Personal agents, on the other hand, are going to perform specific tasks for a user, such as remembering your information when you're filling out forms, name, address, zip code. Email personal agents can auto generate responses, forward incoming messages, and it can also create replies based on the content of your incoming message. Data mining agents work with data warehouses, detecting trends and discovering new information and relationships among data items that were not readily apparent. Okay. Monitoring surveillance agents, they usually track and report on computer equipment and network systems to predict when a system crash or failure might occur. Fuzzy logic, on the other hand, is what is going to allow a smooth, gradual transition between your human and your computer vocabularies. Okay, it's going to deal with the variations in linguistic terms, and it uses a degree of membership in a set. There's some really great graphics in your book in this section regarding the fuzzy logic degrees of membership. Fuzzy logic is designed to help computers simulate vagueness and uncertainty in common situations. It allows computers to reason similarly to the way a human reasons and be able to give approximations and vague data a clear and definable answer. There are many places where fuzzy logic is used. Some of them include search engines, chip design, database management systems, software development, and appliances. If you think about it, you can have dryers that will automatically determine load size, amount of hot air necessary, and even drying time. Smartphone cameras can eliminate shakiness in your image. It will also autofocus and adjust lighting automatically. These are some of the more common uses of fuzzy logic in your everyday life. Now, shifting a little bit away from fuzzy logic, we're going to look at machine learning. Machine language is a process and procedure where knowledge is gained through experience. Machine language is used in several applications such as social media, face recognition, voice recognition, intelligent robots, and artificial neural networks. Artificial neural networks, or ANNs, are networks that learn and perform tasks that are typically difficult with conventional computers. They're typically used for poorly structured problems, as with the expert systems. But unlike an expert system, the ANN cannot supply an explanation because it looks for patterns. Okay, it's not using those if then else rules, it's looking for patterns. An ANN creates a model based on input and output, and it develops these patterns, and that's what's used in order to reach a decision. Here you can see that your ANN has your input and output layers, and there's a hidden middle layer. Okay, this is hidden middle layer is where that learning is going to take place. Okay, that hidden middle layer is going to be trained using past data to start developing those trends. Tasks that involve use of ANNs, all ANNs have to be trained, and you have to remember that when a network needs to be retrained, the ANN needs to be updated, okay? ANNs can be used for bankruptcy prediction, credit ratings, investment analysis, oil and gas exploration, target marketing, and computer and network security. Genetic algorithms are not as widely accepted as the other topics we've already covered, but they're kind of becoming a little bit more recognized in the industry. They're typically used to find a solution to an optimization and search problem. Genetic algorithms are used with problems that deal with many input variables. They find the combination of inputs that generates the most desirable output. We talked a little bit about natural language processing back in module 2. Natural language processing was developed so that users can communicate with computers in a language more closely resembling human language. Okay, natural language can be quite useful, especially when you're talking about databases. The main disadvantage of natural language processing is actually the complexity of the human languages and being able to convert that into that natural language processing system. Some areas where natural language processing can be found are in database interfaces, machine translation, text scanning, text generation for automated documents, and speech systems for voice interaction with technology, things like your Siri and your Alexa. Natural language processing, there are some different activities that can be performed: interfacing and knowledge acquisition. Interfacing is when it is going to accept that human language as input, carrying out the command that it was told, and then generating the necessary output. Knowledge acquisition is using the computer to read large amounts of text, understand the information, and summarize the important parts. And that's what it's going to give back to the user. In order to integrate AI technologies into decision support systems, it can actually greatly improve the quality of your decision support systems. It can add explanation capabilities by using those expert systems. It could add learning capabilities by using those ands, and it can create you can create a user-friendly interface by integrating your NLP system. So into your decision support system, you can actually use several of these different AI technologies in order to fully encompass the whole decision-making system. Benefits of this whole integration, and this is just picking out databases as an example, is you can add deductive reasoning to your DBMS. You can improve access speed and database creation and maintenance. You can add capability to handle uncertainty and fuzzy data. And you can simplify your query operations by having it closer to a natural language. Contextual computing, making mobile devices smarter, computing environment that is always present. You want to be capable of offering recommendation based on who we are, where we are, whom we're with. Okay, new apps in development add capabilities to perceive maybe even a user's mood through analysis, on hearing the inflections in their voice, understanding their text messages, and where they're accessing the internet. This is based on the principle that computers can both sense and react to their environments. Lastly, we're going to talk a little bit about the ethical issues of AI and establishing an ethical framework. First, you need to um, define your AI goals. Okay, define the complexity of your problem. Define the environment as being stable or variable. Define and guard against bias, and define the level of human involvement that you would like in your AI system. This in total is going to establish your um, ethical framework when it comes to AI. So 5 major issues is bias, mistakes, wealth inequality, the impact on humanity, and even the impact on unemployment. And I think I actually have the same slide twice, so we're going to ignore that. So in summary, artificial intelligence technologies, it applies computers to areas that require knowledge, perception, reasoning, understanding, and cognitive abilities. So we're not just saying arithmetic operations, we're actually kind of building in more of that thinking that computers can have. We talked about robotics, expert systems, fuzzy logic, intelligent agents, artificial neural networks, or the ANS, natural language processing. We talked about the implementation requiring an ethical framework and consideration of issues such as your AI bias and impact on that human behavior. So hopefully you enjoyed the watching this on your own time instead of with me live. And we've got one more lecture, and I know y'all can do it. So I'll talk to y'all soon.